So we are already comfortable with basic inequalities. We've also looked at how to tackle higher order where a lot of factors are involved, put them on the number line, figure out a shortcut, alternate regions, etc. And we looked at quadratic equations also, and we looked at a little bit that between the roots, beyond the roots, what is going to happen. That was just one example. So I want to spend a little more time with the quadratic equation, thinking about just spending more time with it and getting more familiar with the story, and starting with an example, and a very interesting example, because this will challenge us in a couple of new ways. So 5x square plus x plus 4, and the inequality given is when is this less than equal to 0. And I invite you to hit pause and try and solve this inequality by yourself, and then start the rest of the discussion. It will be very, very helpful, right? That little bit of a challenge will be very interesting. So I hope you have done that. You've tried factorizing. If you couldn't factorize, maybe you tried finding the roots using the alpha beta quadratic equations roots formula that we have learned earlier, and that means just spend some time with the story. What I want to do is directly notice something known as a determinant, which is b square minus 4ac. Assuming by now everyone knows what the determinant is, it comes from the alpha beta roots of the quadratic equation story. The roots are minus b plus minus root over b square minus 4ac all upon 2a. Always a good idea to revise a little bit, right? So this 4a b square minus 4ac is inside a square root, and depending on whether it's positive or negative or 0, the roots change or behave. We have already covered this idea, so in case somebody is not familiar with this, please visit that chapter again. So I'm straight away going to notice the determinant for this particular story. What is b? B is 1. So b square will be 1 minus 4, 4. What is a? A is 5. What is c? C is 4. So 4 into 5 into 4. So 1 minus, this is 20 into 4, 80, and I will get a minus 79. That means if you try and find those quadratic roots for this particular equation, in this formula, you will have a minus 79. Now, a square root of a negative number simply does not exist as far as our real number realm is concerned. Some of you in high school days, you have already learned imaginary numbers also. So yes, the roots will become imaginary. But as of now, if I say do not know what an imaginary number is, you will say, okay, the root is like this and this can't be worked out. Therefore, there is no root. Okay. And how will that look graphically? How do I interpret it graphically? This is my short form coordinate axis, and wherever the quadratic is, it is hanging in the air. It is not cutting the axis. These are the root points, right? That's what I mean by the root. But this whole story, whatever the value of y is, whatever the function value is, it is never coming to 0 at all. And a quick way to find that out is to check the determinant, whether there is a root at all or not. And if the determinant was 0, I know the root will be the same. Just quick revisions again and again, right? If I create a story like this, that means I can see there are 2 points where the curve is hitting the x-axis, therefore the value of y is 0. Please stop, rewind, make sure that you can also complete these sentences and you know what I'm talking about, right? Because we have covered it earlier. So there are 2 distinct roots. In this case, I know the determinant is going to be greater than 0. And I can also have a story like this where the curve comes and just leaves completely. Typically, it will be something like this. Let's say x minus 2 whole square. And this point is 2 comma 0. So if you create this equation x minus 2 whole square equal to y, you will end up with a graph like this. And that is why the day 0 discussion on graphs in the beginning, so that we are all very comfortable with the visualization, because the visualization is telling me a lot more. So connect it all together. This inequality said less than equal to 0. But if I understand that the determinant is negative, that tells me that the graph is going to be like this. It is never going to even touch the x-axis. That means it is never coming for negativity. I have to come below the x-axis. It is never going to do that. So is it ever possible that this will happen? No, for no real value of x, this inequality will work, right? So it's a tricky question, and I made it tricky because I wanted, because somebody can throw a question like that, and you suddenly find out, okay, I can't find the root. and the roots are strange and I can't find the region, and that's because the equation is such, the determinant is negative, it is not becoming 0 at all, and it is hanging in the air. And now practically try it out. Put a few numbers here. If you put any positive number here, you will see that it will always be a positive number. If you put a negative number here, the negative number will become a square here, and it is getting multiplied by 5. And the negative number here is simply will be a negative number. For example, think of minus 7. So you say this will be a minus 7, but this will be a 7 square 49 into 5, right? So the positivity is so high that even if you keep you make this a bigger smaller number, right, or a bigger negative number, minus 100, but that minus 100 square will become a very big square and multiplied by 5 again. So I see clearly there is no chance, no value of x where this will ever be less than or even equal to 0, right? So long story short, the determinant, a revision of the determinant, a quick way to find out how the roots are going to behave, and some questions based on that we'll later observe in the workshops and the exercises as such. So be aware of the idea. And secondly, a quick revision of roots again. So this is only at 0. I mean, it's so in this case it will never be even be equal to 0, never be negative. Here it is touching going down maximum or going down minimum to 0, and here between the roots it is negative, beyond the roots it is positive. That kind of an example we had seen earlier as well. So just staying with the same idea and one last exploration, because lot of times we say, oh, the graph of the quadratic is going to be like this. But just to be clear, it can also be like this, especially when you make the coefficient of x square negative, the graph will work, the graph will be completely inverted. So how do I handle this story? So how do I handle this story? Just like the previous story, I just follow the rules of logic and mathematics that I've learned for inequalities. So I want to get rid of the minus, right? Because I am not familiar with how, let's say, how to deal with the minus situation here. So let me simply multiply a negative 1 on both sides of the story. So minus 1 into minus x square will give me an x square. This plus 7 will become minus 7, because plus 7 into minus 1 gives you a minus 7. And this minus 12 will become a plus 12. And this 0 will remain the 0, right? But because you are multiplying both sides of an inequality by a negative number, I am multiplying by minus 1. I am multiplying by minus 1. When I multiply by a negative number, the inequality will get flipped. Whatever it is in the previous story, the opposite will happen in the next story if you multiply by a negative number. And after this, I can just work it out. So let me work out the roots. The roots are going to be x. Let me factorize this. It is going to be x minus 3 into x minus 4. And stay with the story less than 0. Now you can go for any which way you are thinking. Now you can plot it on the number line. The roots are 3 and 4. You know, beyond 4 it is going to be positive. Between 3 and 4 it is going to be negative, and less than 3 it is going to be positive again. Just alternating stories, right? And now finally I wanted this, right? I started with this, but the story has now converted into this. So pay attention to the last step. Less than 0, that means I want negative. That means between 3 and 4. So my final answer would be x is greater than 3 and less than 4. So now you can check that for yourself also. This inequality solution is going to be x is greater than 3 and less than 4. So that is one way of going about it. But the idea is that even when it's inverted, it is following exactly the same logic. So I should be clear that even for this story, the roots are 3 and 4 only. So again, start with the same equation, or you want to, or the same inequality. And this time I don't want to apply the negative game. I want to factorize this only. What if I write it like this? X minus 4 into 3 minus x. I think check for yourself. you can also write it like this, x minus 3 into 4 minus x. Either of these situations will give you this quadratic equation. So x into 3 will give you a 3x. A minus 4 into a minus x will give you a plus 4x. You had a 3x earlier, 4x, 3x, plus 7x. And a minus 4 into a minus 4 into a 3 will give you a minus 12, and a x into a minus x will give you a minus x square, right? Try the same thing with this expression as well. And even for this, the roots are, if you make x is equal to 4, this will become 0. If you make x is equal to 3, this will become 0. And what does the negative coefficient of x square tell me? And it starts very easily, right? Draw out y is equal to x square and y is equal to minus x square. Y is equal to x square will be perfectly like this. This is the 0, 0 point. It will come, touch at the 0 point and go up. And the graph for minus x square is going to be the complete inversion of this. So we are learning for later also that a negative function looks like a complete inversion, or what we call a water image. Don't worry about the term right now. But and the best way, again I'm telling you, right, just in case you're not familiar with this and you want to become good at this, you just sit down, make a table of entry, input, output, buy some graph paper, plot it on the paper, so that once you are very, very clear, and if you are already clear, you must know that you must have also understood it like this only, at least once it needs to be clear in the mind, right? So this graph will behave like this, still behaving like a quadratic. There are two roots, 3 and 4. But now what is happening? Between the roots, it is positive. So if I factorized it like this, but I understood that the graph is inverted, the question said greater than 0, so I am looking at between the roots. Right? So sit with this idea and understand what are the all possible scenarios for a quadratic equation. There are not too many. You will either have a ax square plus bx plus c kind of a story, or you will have a minus ax square plus bx plus c kind of a story. It doesn't matter whether there is a negative here or not. This is the major determining factor, whether the coefficient of x square is positive or negative, right? When it is positive, when it is a straightforward quadratic equation, what are the possibilities? If there are roots, and when are there roots? When b square minus 4ac is greater than 0, or you directly see it in the factorized form anyway, you will know that there are roots. If there are roots, between the roots it is negative. Beyond the roots it is going to be positive. Right? We have already seen this without drawing the curve, but this time I want to get familiar with the curve as well, so that for later conversation we have some confidence with this, right? And what else can happen? The curve could be in air, that means there are no roots, that means this function will never be negative, will always remain positive no matter what value of x. Or I could have a situation where the graph just comes, touches and goes away. So minimum it goes up to 0, the y value becomes 0, but it is never negative, right? So I have clarity there. Mostly this is my standard form. But I just want to create the opposite of this also. I have a quadratic equation like this. That means between the roots it is positive, it is visible to me visually, above the x-axis is positive, and beyond the roots it keeps going down as you want, and a minus here. So get comfortable and familiar with both of these graphs, and they should be available in your memory bank at instant recall. Yeah, minus x square, that means the graph is upside down, and between the roots is going to be positive and beyond the roots negative. Normally between the roots negative, beyond the roots positive, right? Anyway, this is just for more deeper mastery. As far as inequalities are concerned, the shortcut that we have learned earlier will work for almost everything. This is just trying to connect it to the quadratic equation, and especially the determinant, the importance of determinant. In case you are unfamiliar, please revisit that chapter.